Hello guys, welcome back to TechDose, and in this video we will look at maximize the number of target nodes after connecting trees to problem, which is from Leetcode number 3373. A prerequisite before watching this is to know all about BFS. If you have any confusion, then please watch my video and the link will be shared in the description below. Let's now look at the problem statement. There exist two undirected trees with nodes n and m labeled from 0 to n-1 and 0 to m-1. You are given two 2D integer arrays edges 1 and edges 2 of length n-1 and m-1, where edges 1 at I is representing ai bi, indicating that there is an edge between the nodes ai and bi in the first tree, and edges 2 at I equals ui vi, indicates that there is an edge between the nodes ui and vi in the second tree. Node u is a target to node v if the number of edges on the path from u to v is even. Note that a node is always target to itself. Return an array of n integers answer, where answer at I is the maximum possible number of nodes that are target to node I of the first tree if you had to connect one node from the first tree to another node in the second tree. Note that the queries are independent from each other. That is, for every query you will remove the added edge before proceeding to the next query. Okay. Now let's look at the example given. So in this first example, you can see that we are given edges 1 and edges 2. So edges 1 is marked as 0, 1, 2, 3. And we will be taking the number of nodes here as n. Now since this is a tree, therefore we know that we just have a single component. There is no cycle at all. That means there is no redundant edge. And due to these two properties, the number of nodes will always be equals to number of edges plus 1, and that is why the number of nodes in the first tree is going to be edges plus 1. Edges are 4, so this is going to be 5. And similarly, if I mark all the edges in the second tree, then the number of nodes are going to be 7 plus 1, which is 8. Now these two trees are already represented here, as you can see. The problem is asking about take each node from tree 1 and try to connect them with the optimal node in tree 2. What is the meaning of this? Let's say that I take this 0 node, okay, as the source node, and I try to connect it with one of the nodes in tree 2. After connecting, I have to count the number of nodes present at the even level, considering that the source node is at level 0, which is even level. So this will be one count contributing to the even level. This is now odd level, right? This is odd level, so it will not be contributing. Now if you see, these nodes are even level, and so this will be contributing. And what is the count? 1, 2, 3, 4, 5. So this is contributing plus 5. The next level nodes, these nodes are odd level and it will not be contributing. And the next level nodes, these are all even level, so this will be contributing plus 2. So if I connect node 0 from tree 1 to node 0 in tree 2, then the total number of nodes at even level that I get is 1 plus 5 plus 2, which is going to be 8. Okay. Now I just connected this node 0 to node 0 in tree 2, and I found that I can get maximum even level nodes as 8. But this may or may not be optimal, right? This may or may not be optimal. So maybe connecting to some other node would be more optimal. So what may happen is, what happens if I connect this node 0 to node 2? Then how many count do I get? So after this, whatever is the count you get at even level, again you can try connecting node 0 with node 7, node 0 with node 3, and so on. So after trying out all the possibilities, you will see the maximum count of node 0 connected to node 0 in the another tree will give you 8 count. Okay, and 8 count is the maximum. Therefore connecting 0 to 0 will be optimal. And also if you had connected this 0 to 7, it will still give you 8 count, which will again be optimal, right? So I do not care about where this node 0 is getting connected, but I just want to maximize my count. And since the maximum count is coming at 8, therefore the answer for 0 is 8. Again, we have to repeat this process for node 1. For node 1, if you take this as the source node, then if you connect this 1 to an optimal node in tree 2, let's assume that the optimal node is 0. I don't know which one is the optimal node. If you connect it to 0, then what will be the total nodes at even level? So this is +1. Now the next level, this 0 will not get counted, and this 0 will also not get counted. This is level 1. Now this is at level 2, and these all are at level 2, and these will all be counted. So 4 nodes will be counted, 1 plus 4. Now the next level, level 3, level 3, level 3, level 3 will not get counted, and the next level, these two at level 4 will get counted, and this will be contributing +2. So the total count is coming out to be 7. Okay. In this case, the optimal result will come if you connect 1 to 0. But you will have to try all possibilities, isn't it? You may have to try connecting 1 with 2, 1 with 7, and so on. So since the maximum even level count when you pick 1 to be the source node is coming out to be 7, therefore the answer for this node 1 is 7. And this is how for all the nodes in tree 1, the answer is calculated in the form of an array as the maximum number of nodes that you can cover if you connect the given source node to any of the optimal node in tree 2 in such a way that my goal is to maximize the nodes at even level. Okay. So I hope this is clear. Now let's say that for 0 I was trying to connect to this 0. Then what will be the time complexity to do this entire BFS? If you have n number of nodes in tree 1, m number of nodes in tree 2, it will be n plus m, because edges and nodes are equivalent, right? So that is why it will be n plus m. Now if you repeat it for all the nodes in tree 2 for every node in tree 1, then that will have a multiplication factor of m. So this will be order of nm plus m square. And you know that this has to be repeated for all the nodes in tree 1, which is n number of nodes. So then again you will have a multiplication factor of n. So that will make the time complexity n square m plus m square n. And you know that from the constraint section, n and m has maximum value of 10 to the power of 5. So this will be 10 to the power of 15, and this will be 10 to the power of 15, which is way beyond your 10 to the power of 8. We should write an algorithm which runs in computations less than 10 to the power 8 to pass within 1 second, which is the expected time complexity, right? So this is definitely not going to pass. Even though we remove this n factor, it will still not pass, because again nm is 10 to the power of 10. It will still not pass. So we have to write an algorithm somewhere similar to n plus m, or you can have maximum a log factor involved along with this n plus m, but we cannot exceed the complexity, right? Otherwise we will be exceeding 10 to the power 8. So I think you have understood the problem and the expected complexity. Now let's look at the constraint. So in this case, n and m values are maximum 10 to the power of 5. Edges are n minus 1, m minus 1, as you know the number of nodes being n and m, right? The edges are represented as u comma v format, indicating there is an edge between u and v, and rest all are self-understood. Now having understood all this, let's look at an idea like how to do optimal connection. Now if you assume this to be tree 1 and this to be tree 2, then how will you know what is the optimal connection for this node 0? So let's pick this node 0 to be the source node for our first iteration. And let's say if this 0 gets connected to this other 0, then whatever count you get, what is that count? It is equals to, here you get 1 and here you get +2. Okay, at even levels. This 0 is at odd level, so I have already marked the odd level nodes, and those will not be counted. 0, 4 and 7 will not be counted, whereas the other nodes 2, 3, 1, 5, 6 will be counted, and this total count is giving you +5. And you already got 3 count from the first tree, so the total count is going to be 8. 3 plus 5, right? Now how do I know if this 0 is connected to the optimal node in tree 2? Well, if this 0 was connected to the node 0 in tree 2, and whatever count you got, let's say you got count +5, then you will get the same count even if this 0 was connected to this 7 or this 1 or this 4. All of them will give you the same count. And why is that? Because if this 0 is at odd number of level as compared to when you start with the source node, right? So this comes at an odd level jump. So if you connect to any node at odd level, like 0. 0 is at odd level. If you assume 0 is at odd level, then 7, 4 will also be at odd level, right? This is level 1, then this will be level 3, something like that. So you connect with any node. You connect with 7, 0 will be again at odd level and 4 will be at odd level. Rest of the nodes will be at even level. So you will get the exact same number of count at even level, which is 5, and at odd level, which will be equals to 3 in this case, right? Because the total nodes are 8. So what we need to optimally do is try out with any node, try out with 0. Connect this 0 with 0, and whatever count you get, let's say you got plus 5 from the second tree, then you try connecting it with an adjacent node to 0. Because this is a tree, it is a single component system, so you just connect it to one of the adjacent node of 0. Just try it with 2 and see what count you are getting. If you connect it with 2, then the count you get is all of these odd levels nodes will now be present at even level, because this 2 became at odd level now. Then if 2 is at odd level, then this 3 will be at odd level, 1 will be at odd level, 5 and 6 will be at odd level. So we are actually flipping the levels and the node numbers, right? So if you connect 0 with 2, you will get count 3, which is 2, 3 and 1. So 3 nodes will be actually accounted for, right? So out of these two options, one will be the optimal option. So we just need to try with 2 adjacent nodes. We don't need to try with all the nodes. Whatever may be the number of nodes in tree 2, you just need to try with 2 nodes. Connect with one node, pick any node, pick 0, and then you try with 2 or you try with 1, whatever is adjacent to 0. It can be any node, right? So one of these 2 nodes will be giving you the maximum count for sure. I think it is clear, right? So if one of these 2 nodes are giving you the maximum count, then what we have to do is we have to just calculate the best option possible. We have to see that in tree 2, find out the count of nodes at even level, and then the count of nodes, total count of nodes m. What is the total count of node? Which is edges plus 1. How many edges do we have? 1, 2, 3, 4, 5, 6, 7. That can be found from the edges dot size, edges 2 dot size, right? So we have m value as 8. And if you start with, let's say, 0 and assume that 0 is at even level, then count the number of nodes at even level. So if 0 is at even level, then you will find that 7 and 4 are also at even level, isn't it? So you will get a total count of 3. So what will be the count of nodes at odd level? Total number of nodes minus the nodes at even level, which will be coming out as 8 minus 3, which will be 5. So which will be optimal? Even level or odd level? Take the max of this 5, 3, and that will be the result. So you will always get the maximum optimal, counting if you connect it to the max of even, odd, because a node can be converted to even or odd depending on which node you are connecting this source node to. If you connect 0 to 0, 0 becomes odd level, and if you connect this 0 to any adjacent node of 0, that means let's say 2, then 0 will be at even level, right? So I think you have got the idea what we need to do. Now let's see how to count the maximum nodes at even and odd level. So if you look at it, it is the tree number 2, and in this case, if I start the counting process from node 0, then I will assume that it is level number 0, and I can keep an even counter. So I will be pushing it into the queue, where I will be pushing just a single node, finding the size of the queue and adding it to the even level counter, and then pushing all the adjacent nodes into the queue at level number 1. So level number 1 nodes will not be counted, and then again when you push its adjacent node 7 and 4, this will be level 2 and they will be counted. And so at level 2 when you go, then the queue size will give you 2 size, that is 7 and 4. So 2 will be added and the even counter will become 3. And again at the next level, this is level 3 and this will not be counted, right? So after doing BFS starting at node 0, where we will be assuming node 0 belongs to even level, then the even level nodes will be 0, 7, 4 and the total count will be 3. You know that the total number of nodes in tree 2 will be edges.size plus 1, and so here it will be 8. Okay, so the total number of nodes are 8, and nodes at even level that we found is 3. Therefore the nodes at odd level will be the total nodes minus the nodes at even level, which will be 5 in this case, right? So as I already explained, if we count the even level starting from either 0 or 7 or 4, it will come out to be the same. Okay, it will come out to be the same and it will come out to be 3. Otherwise, if you count from any other node, like let's say if you had started the count from 2 for the even level, where you assume that this is at level 0, then it will be including 2, 3, 1 and this 5 and 6, right? So in that case the even count will come out to be 5. So it depends on what you are assuming and where you are starting, but in either way, wherever you start, it does not matter. It does not matter, because I will always try to take the optimal start point, and in such case, if you have two options of count, then I will be taking the maximum of these two options, right? And that is why the best option will be taken between the even and the odd count. So even count, if it is even, odd count can be written as the total number of nodes m minus, you can say, the even count, which will be equals to the odd count. So I think this is clear. So this is the pre-processing done on tree 2. Okay, pre-processing on this tree 2. Now what about the tree 1? Actually in tree 1 as well, you don't have to apply BFS all the time. You don't have to apply BFS, because if I know that 0 is at even level, then I can mark all the even level nodes by just doing one time BFS. If you just do one time BFS, then you can mark all the nodes at even level. So if you get an you know the count of number of nodes at even level at 0 to be 3, then it does not matter whether you start counting from this node 3 or from this node 4, you will still get the count to be 3. And for the odd level, if you start the count of number of nodes which are at the even level starting from this node 1 or node 2, you are still going to get the same count, which is 2, and this count will be equals to the total number of nodes 5 minus the number of nodes at even level, which will be 2. Okay, so that kind of pre-processing we can do on tree 1, where we can start at any node and assume it to be level 0. So in this case I will be starting with node 0, assuming it to be level 0, and we need to mark all the even level nodes starting from node 0. So I can take a included array of size n, where n is the number of nodes in tree 1. Okay, and assign all of these node values as false. That means none of them are included at even level. When I start at node 0, I will be marking it as true. Okay, and I will be keeping a even level counter starting from 0, and then try to parse the next level. The next level will be all level 1, which is odd. So no addition will be done for even level. I just added 1 for the start point. Now when you go to the next level, this is level 2, and so 3 and 4 will contribute to 2 size in the even size counter. So that will be adding 3, and 3 and 4 will be marked as true in the included array, right? So after doing the entire parsing, you know that even level nodes are 0, 3, 4. That means even or not, what I'm trying to do is I'm trying to segregate the nodes at one level from the other level. So 1 and 2 will be at the same level, whatever you assume even or odd, and 0, 3, 4 are going to be at the same level, right? So even count is 3, the total count is 5, so the odd count will be 2 as well. So now after doing this pre-processing, this can be done in just order of n time. After this pre-processing, if you give me any node and ask me about how many total nodes we can cover from this node, then I can give you it the answer in order of one time by just looking at if this one is already included at even level or not. So it is saying false, it is not included. That means whatever is the even counter, 3 in this case, and total count, which is 5, I can return 5 minus 3. That means 2 nodes will be covered if I start the BFS from 1 and try to cover all the alternate levels, right? So this is how you can optimize the solution, and you can do each query in order of one time, having done the pre-processing in order of n time. Now let's see the dry run. We have a 3-step process. The first step is to find the best level count in tree 2 that we have already seen. How to do that I have explained in step number 1, where you can just assume this 0 to be at the even level, get the even level count, which is this one is at even level, this one is at even level. It was coming as 3. Total number of nodes was 8. So the odd level count was equals to 5, which is 8 minus 3. Take the best option, which is maximum of even and odd, and that will be equals to 5. So whenever any node from tree 1 will get connected to any other node in tree 2, it will always give you the best possible count if we want to maximize the count. Okay, so that was step number 1, which I had shown. Step number 2, mark the nodes at even and odd levels in tree 1 and get the even count. So I will be again starting with node 0 in the tree 1 and marking it as even. Okay, and get the even level count. Even level count was equals to 3. Total number of nodes are 5, and so the odd level count will be n minus e, which is going to be 2 in this case, right? So I have to also mark all the nodes at even level 0, 3, 4. So those are already marked as I shown in the previous step. So this is step number 2. Step number 3 is we need to iterate for all the nodes in tree 1 and try to build the answer. So what will be the length of answer? It is going to be the number of nodes in tree 1. For this node 0, how will we calculate the answer? We will see if this node 0 is at even level. Yes, it is at even level. So I can get the even level count 3. So 3 will be added to the best option because I will connect optimally to one of the node in tree 2 so that I will get the best count, and that will be equals to if I connect to this 2, right? But I don't care where I connect. So I can just add the best option and it will give 8, and 8 will be the answer. Now, if I have to see for this 1, then check it out. If it is at even level or odd level, it is at odd level. So get the odd count. It is equals to 2. So add 2 to the best option. That means the best count from tree 2. So that will be 7. So add 7 here. For this node 2, check it out. This node 2 is at odd level again. So get the odd count 2 plus the best option from the second tree 5. So this will also be 7. If you look at this node 3, this is at even level. So get the even count 3 and add the best option from the other side. 5 plus 3, 8. If you look at this 4, then check it out. It is at even level. So get the even count 3 plus the best option from the second tree 5, and that will be 8. So the answer is 8, 7, 7, 8, 8. Okay. Now in this entire process, tree 2 pre-processing will take order of m time. Then tree 1 pre-processing will take order of n time. And on top of it, we are doing just order of n as the total number of operations, okay, to build the answer. So the total time complexity can be said to be n plus m, right? And you will see that total complexity is n plus m, where n is the number of nodes in tree 1, m is the number of nodes in tree 2. The space complexity will be n plus m, which is taken by the adjacency list as well as the BFS. That means the queue. So I hope this entire approach is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. If you look at the main function max target nodes, we are given edges 1 and edges 2. So I'll be calculating the number of nodes, which will be edges plus 1, and then I'll be taking the adjacency list. So building the adjacency list for both the trees. So these are undirected graphs. So if you have an edge from U to V, there will also be an edge from V to U. And now I will be showing you all the steps one by one. So what was step number 1? Step number 1 was pre-processing done on tree 2. And what was that pre-processing? Assume that node 0 is at level 0. And then we will try to do BFS just to find out the even count of nodes starting at node 0, and that will be stored in even count 2. Then if I have to get the odd count, that will be the total number of nodes in the tree 2 minus the even count, which will be odd count. So the best option will be max of even count comma odd count in tree 2. Okay. So that was step number 1, pre-processing on the second tree. Step number 2, pre-processing on tree 1, which will be actually tracking out. If you have a tree, then I will be assuming node 0 to be at level 0 and try to do BFS from node 0. Then I will be marking in the included array that if node 0 is marked as level 0, which is even level, then what all nodes are at even level, those will be marked as true as well, and rest of the nodes will be marked as false. Okay, whichever are not at even level, those will be marked as false. So that will be the update in the included array. Included array was of n1 size, which is number of nodes in tree 1, and initially none of them are assumed to be at even level. After this BFS call, the even level nodes will be marked, and so the even count will also be returned, which will be saying about how many nodes did we see at the even level in tree 1. Using this, you can subtract with n and get the odd count as well, right? So this was pre-processing in tree 2. I will show you the BFS function as well. But before that, step 3 was now take one node after another from tree 1 and see if it is actually at even level or odd level. So if it is at even level, then add the even count from tree 1 and add the best option from tree 2. Otherwise, if the given node is at odd level in tree 1, then add the odd count from tree 1, and still you have to add the best option from tree 2. Okay. Now if you look at the BFS call here, then you see we have the start point of the BFS, the adjacency list. Now this included will work for one of the BFS call and it will not work for another BFS call, and that is why it has been assigned with the null pointer. So if you look at the two BFS calls that I have made below, then the first time I call BFS is just for the count process. It is not for marking the included array. Okay, so that is why the third parameter is not present here, whereas the third parameter is present for counting and marking the included array. Okay, so instead of writing two BFS calls, you can write one time. That will be easier, right? So this will not work for the first BFS call, but this will work for the second BFS call. Okay, now we are doing simple BFS, counting the nodes at even level, and this is the piece of code which will just run for the second BFS call, where you have an included array. That means included was passed in the parameter, and we are looking at the even level. Then we have to mark the even level node to true. That's it. Otherwise the rest of the code is the standard BFS code. Okay, so I hope this is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.